Applause. Thanks, mate.
Thank you, Byron. Okay, thank you. Good to be here with everyone again this year. So I had to rewrite my presentation a little bit. Thanks, Anna, based on the VBA practice guide coming out a week ago. But when I saw it, it was something I really wanted to talk about today because I read through it and it really aligned with a lot of good things that we've been doing day to day for the past few years. So we're going to have a part 1 and a part 2, and they're actually very closely related, right? Because when the NCC 2025 comes in, there are going to be changes that you're going to have to accommodate in your design and your construction, and the practice guide talks about how we can best do that. So a little bit about me up there. What I actually want to talk about, I had a sort of few questions about, obviously, Byron Stan and I have been running this now for a few years. You know, how did you get into events and how's that related with what you do in waterproofing design? And I think it really ties back to the reason I got into this. And it was about 5 years ago. We actually just had our 5th birthday for waterproofing integrity. And at the time I saw, because I've been in waterproofing my entire career, and I saw a lot of the experts, or the few experts that were helping projects and the really good outcomes that they were achieving at that time. And the catalyst for the founding of Waterproofing Integrity was that idea that, man, how can we get that level of help and those good outcomes across more projects? And I had 2 ideas at the time on how we might be able to go about that. First one was to actually just kidnap Ross Taylor and clone him. We almost went that way. But instead, what we thought was, let's create a scalable business that brings in, new blood into the industry, architects and engineers that can actually have a pathway into waterproofing design. So it was that concept of how can we help more people? And that's what we're trying to do here today by sharing this information, prepping everyone, getting good outcomes for you and your projects in the future. So NCC 2025, I'm going to build on all the things that Ross talked about before. We did just have our public comment draft. So I've modified this slide from when I did it in Sydney. We're actually in the public comment draft process at that time. So that's now finished. And what's the point? What's the point is that there is a process to updating the NCC. Now, I wish we had one of these for the current process. This is actually the last NCC when we had 2022 revised. So this is a little bit of a roadmap they use then to say we're going to have multiple stages of public comment review. I assume the same thing will happen this time. And then it will go into adoption stage and whatnot. So what's it mean for us? Well, it means that there's change coming, right? Pretty simple. What are those changes going to be? The way I'm going to explain that is just by working our way down from the hierarchy of the NCC. I'll start at the objectives and functional statements, touch them briefly before going into the more important performance requirements and then the new DTS provisions that we've got. So our objectives, and I think there's a really good consistent theme to this of the simplifying of things and the taking out of complexity. Water is water. And just allowing the document to be more usable. So one of the introductions here is that we're protecting the internal surfaces caused by the damage of entry of water. And we've taken out a lot of fluff in the middle there. And we've also simplified it down to just water there. So really makes the objectives nice and clear. Functional statements are really more of the same. So you can see we've taken redirected surface water and it's just protection from water now. Excellent. And then in our functional statement number 2, we've really looked at making that more about below ground, because historically addressing below ground requirements and outcomes was gravely lacking. So it's really good to see this in here that we've carved this out. It's not about rain and surface water anymore. It's about rising damp and groundwater for functional statement 2. So performance requirements. This is the meat. This is the NCC as a performance-based code. So these are the things we're aiming to meet. And in our previous iteration, being 2022, we actually had 5 of our performance requirements. That's been condensed down now so that we effectively only have 2, performance requirement 1 and 2. And the first one we're going to talk about is P1, obviously. And as my nice arrows are showing up here, P1 is about managing the impact of rainwater on the building. So it's pretty much everything above ground in a nutshell. So we'll go into a bit of the clauses here and have a look at them. So this is the most important one. It's Water collected and concentrated by a building or associated site work allotment must be redirected to prevent A, B, and C. It's unhealthy or dangerous conditions or amenity, damage to internal surfaces, or nuisance to another building. Okay, so Ross touched on this one quite well, really condensing down water into from all of these things that were randomly mentioned, opened up a lot of dispute about, well, I don't have to protect against this one, I do have to protect against that one. So now we've just got plain old H2O, and that's what we're protecting against. So this one here starts to get a little bit complex and mathematical on us, but we do have to define how much water we have to. So we've got our 5-minute duration period. So we need to collect and dispose of it in a way that avoids likelihood of damage to the building. And it also needs to be conveyed through a drainage system. So that's a 5%. That's also a 1 in 20 year event, if anyone's more familiar with that terminology. And then we go to the next clause. And now we're talking about a 1% event. So these are actually our 1 in 100 year events. They're a lot more intense, and we have a little bit more lenient things here. So we effectively need to shed water away from the building as well there. So I'm going to grab a drink of water here quickly, guys. Okay. So I did have to cut a couple of slides out here that talked about what our annual exceedance probability is, so I could talk about the Design Practitioner's Guide. But the important takeaway that I'm going to move through quickly here is that we need to make sure our buildings achieve their amenity outcomes, they prevent dangerous conditions or the health of our occupants being damaged, or internal surfaces. So this is where I really just simplify it down. So what we're trying to say is that the rainfall intensity must, where it's greater than the peak runoff, we get surface water accumulation. So to really make it simple, and all that jargon we had up there before, it was that you need to be getting water away from the building faster than it can accumulate in a 1 in 100 year event. So I've got a couple of videos here which shows what happens when we do not achieve that. Not sure if we have some volume here. It's not really critical, but I think I'm getting some help behind the scenes here. Nope. So the first one was water gushing against the building there. This one, we have effectively the same thing. We have such a high intensity of rainfall, not outside our 1 in 100, but it's too much for the drain point that's existing in the middle there to handle. Oh, here we go. So it is surging up against the door. It's imminent that it's about to come into the internal space. So this is definitely not satisfying our objectives that we were trying to do. Similar situation here. That's a pretty solid amount of water that we've got on that balcony there. Now you might not. So there is actually a drain point there. It's behind that plant. However, there's no falls in this balcony, so water is accumulating and staying in place faster than it can move to that drain. And this is the exact thing that we want to prevent. So this video doesn't show it very well, but when that water is accumulating there, it is making its way in through the doorway, also because it wasn't detailed very well. But it's when you have these combination of things that are deficient is when you start having these failures of water ingress. So now moving on to part 2. Remember, part 1 is above ground. Part 2 is going to be our below ground. And this is effectively what we're working with. So rising damp and groundwater must be prevented from causing undue dampness or deterioration of building elements, and also unhealthy or dangerous conditions, loss of amenity for occupants. Very logical outcomes that I think we all agree we do want to achieve in these scenarios. And then we also have an exemption down the bottom there. Okay, so here's my diagram, pretty much just reinforcing that point that we do want to stop our groundwater from causing a problem to our internal space. Now, a key change is the removal of the exemptions for class 7 and 8 buildings. So historically, and I think this was a huge flaw, in the current and previous versions of the NCC is that it had these exemptions in there, and the way it actually played out in the industry was that certifiers were unable to really make any demand of their clients to say you need to have something in place here, because the way these exemptions were worded, whether it was intended or not, it's how they were used. So the way it played out was, we just don't even really need to think about it. We don't need to prove that it's good enough. We don't need to think about, oh, it's a car park, but we've got plant room with sensitive equipment. We've got storage cages directly against the wall, which is potentially a wet wall, the mold that might aggregate from that. So it's excellent that that's been taken out, because it does make a big difference in preventing this sort of situation. I can tell you, and I will play this. We go. We got a bit of sound there. I need my ominous music. There we go. So a lot of these situations, this is taken from various projects, they were resultant from designs just excluding. No one had wanted the liability to talk about it, so no one thought about or designed in how the water would actually work in these scenarios, and they did it off the back of, these are car parks, it's exempt, we don't need to think about it. So a really good change, because I don't think anyone, or I hope not at least, that anyone in this room would want to argue that these are actually acceptable things that you would want to have in one of your properties, or have your family exposed to. So the question is then, if we're now needing to address this new, very clear, very solid, below ground performance requirement, how are we going to do that? And see if I've got a laser pointer here. No, that's the back button. Okay, I do put a note on there that says that this is currently available. So this is what we're working with right now. Likely there will be adoptions of things in the future. So you see I've effectively taken a standard there and rewritten it as below ground structures. It just doesn't exist at the moment. There is intent. It would be awesome to have a standard to help everyone design and build in a clear way. We just don't have it at the moment. So under the NCC, we've effectively got two pathways, or a combination of those. And if we don't have deemed to satisfy, then we do have performance solutions. So that's effectively what we're looking at. Okay, so I think we have a pretty varied audience here. And the question might be, well, how do we do performance solutions? Everyone's thought of them as quite a big, scary, daunting thing that's going to take a huge amount of time and a huge amount of cost. And in some instances, that's true, but it's the same with anything. The more you do it, the more effective you be at moving through the process. And it's definitely not as scary as anyone might think. So what we've got here is our performance solution process that the ABCB's actually put together. Great document. It's very, very detailed, perhaps intimidatingly so, but it shows a very clear way of approaching performance design. And what I've got here, these might be a little bit difficult to see because there's so much detail in them, but they're effectively three different basement designs. So we treat them in columns. On the left-hand side, we've got the ground level, halfway down, and the bottom level of the basement. And then in the other two columns as well, that's a different design. So these are all very different designs, but they will all be valid as a performance solution in different scenarios. So to use it comparatively, the one we have on this side here has a full continuous pre-applied waterproofing sheet membrane, big plastic bladder around the building. And then we have a drain cavity on the inside as well. So we actually have two lines of defense. So this is a pretty robust system where even if you needed to have habitable space on the inside of the basement, you would be pretty confident that you've got enough protection measures in there to offset the potential hydrostatic risk from the water outside, right? So that's something more robust that you might use when you have a higher consequence or even higher water table on the outside, higher risk. And then we have in these two here, I'll just combine them in my explanation. You have a little bit more of a limited amount of protection. There is no continuous waterproofing barrier. We do have different types of drains. We have a concealed cavity drain there, and then we have just an open wet wall here. And I'm not saying that every basement should be tanked or whatnot. I do think that there is a place for allowing a controlled amount of water in, but the key word is controlling it. And if you can prove that, and this is what performance solutions are, they're big proof documents, effectively. If you can prove that the water or dampness that you are allowing into the space will not impact the finishes, it will not impact the health or amenity, and it won't impact the structure, those are our performance requirements, right? So that's the decision-making process that you go through with a performance design, and it's what you can expect to see that the industry is going to attend to a lot more carefully now that we actually have these clear requirements in place. So that's our performance requirements, right? We're working our way down the hierarchy period here. We've covered our performance requirements, our outcomes we need to achieve. Now we're going to have a look at our new DTS provisions that have come in. Ross has touched on these previously. I'm going to elaborate and give a little bit of examples, and we're going to work our way through all of the parts 1 to 15 just for clarity and conciseness, even though there's a couple in there that don't have any changes. Speaking of which, D1 to D3. For expediency, I'm just going to note them, but we are going to skip past them. I won't rehash what they are, but there's no change there. So now we get into D4, which is our interesting one. We have a very clear statement about the structural substrate having a minimum of 1 in 80 fall. And then also something that we previously had was our drainage system that needs to convey the water in accordance with our hydraulic standard there. So that's our first point, 1 in 80 in the structure. Now, this is where it starts to get a little bit more nuanced in the way that you've got to read these, and I'm going to give some examples on each of these. So I'm going to jump straight into A, and then we'll progressively work through the examples on B and C. So for A, we've got 70 millimeter step down, and the words are very important here. And like Ross touched on, there probably is some fine tuning. So 70 millimeter step down from the internal floor level to the external structural substrate. So here, this is a fire stair. You can see that the external area there, external exposed rooftop, has a waterproofing on it. We've got a very clear 70 mil step down, nice and simple, right? Then we look at this one. And I want to point out that when we talk about these things, even with our waterproofing freeboard height in our current external waterproofing standard, everyone is very focused on the doorways because I've got to have a step, I'm going to trip over it, it's not good for accessibility. All of these requirements are equally applicable to walls as well. You need to get that continuous waterproofing upturn, structural upturn in this case. And that's what I'm trying to show off here. So 70 mil step down in our wall. Excellent. So now we've got something a little bit more complex here. You can see we've actually got a quite large 140 millimeter step down here. And if you follow the direct words there, we've got our external structural substrate, and then our internal is all the way up at 140 millimeters above. So quite good. Now, this is the point which needed a little bit of clarity, right? Because in this particular image, you can see that we've got a flush transition there, and our concrete slab is also almost flush. And it does actually comply with the current wording, but I know that the intent here was to actually have a structural step up so that we have a structural barrier. So one of the public comments I made, and I'm sure others did as well, was to look at that wording and say, we know the intent is to have a structural fold there. So currently this detail is actually compliant with that, but we're expecting revisions to be made off the back of public comment that will fine tune this. So we'll see that when that comes out. And we've got the next year or so to work up towards it before we need to start designing and constructing these. So now we move on to point B, which talks about having hobs. Nice simple example here of a 70 mil hob around the perimeter, tile and pedestal on the inside. And some good drainage as well. Similar but different here, we have tile and screed on the inside. Still has the 70 mil integral hob around the perimeter. And so the question is, if we need to have a 70 millimeter integral hob around the perimeter, do we put another hob on top of the step down that we already had? Well, to answer that question, we have clause number C. And what it says is that you don't need to put the hob where you have an external structural substrate that abuts an external wall. And again, the wording there's a little bit tricky. So I put up a diagram here, which clarifies where you need to have a hob, where you need to have a step, and also where we have a wall which is external to external, where you don't need anything at all. So I think this clause is actually really well worded. It just takes a little bit of time for you to get your head around. Cool. So yes, we've clarified that we do not need an extra 70 mil hob on that step down. If we have any concreters in the room or anyone that's in the know, I'm sure you'd agree that that would be extremely hard to form, both a set down and a hob on top of each other. So very good to know. Point number 5, substrate materials. So we now have this new clause which pretty clearly states that the structural substrate can consist of either reinforced concrete to AS 3600 or an FC sheet that complies with AS 2908.2. And of course, it needs to be free of any variation or defects that would impact the performance of the membrane. So that gives us a very narrow scope of what you can apply your membrane to. Because just to be clear, the substrate is the surface to which you apply a membrane. So you can apply a membrane onto those, but not anything else currently. So let's have a look at some diagrams here to explain that. Here are our 2 compliant substrate. Well, the reinforced concrete isn't poured yet, but you get what I mean. Cool. Now, we have established that, I'll just go back. We are going to talk about this a little bit more in future slides where it combines with another clause. But just for now, just remember, those are our 2 substrates that are acceptable to apply a waterproofing system to. But before we do that, we're going to talk about exposed joints. And these have been bolstered up a little bit here. So we really have 4 things that we need to cover. So the joint must now be located at a ridgeline, at a high point. So high point is created by the drain points being the low point. You need the water to fall to the drain. If you make sure that you have your movement joint, which has a hob and whatnot, at the high point, you're never going to get into a scenario where your water is trying to run to the drain and it gets blocked by a nice structural movement joint here. Point number 2 is that it must have a hob on either side. We've seen plenty of movement joints that are built with just 2 flat slabs abutting against each other. That doesn't provide any structural upturn barrier to water leaks that might occur in that scenario. So we now must have a 50 mil joint on either side. Point C is that it needs to be protected in accordance with our external waterproofing standard. That is where that detail shown on the left there is taken from, is our external waterproofing standard. And finally, and this isn't a new one, this has been in the NCC 2022, and it says that these joints must not be located or run through a planter box, water feature, or similar part of the building. Now, a question we get on that one is that, well, this is just movement joints, right? We agree that movement joints shouldn't run through a planter box. But what about my CJs? Like, this doesn't apply to that, right? Well, we have our note in the NCC here, which states very clearly that for the purpose of this clause, an exposed joint is a construction joint, control joint, expansion joint, contraction joint, movement joint, or any other type of joint, right? So don't fall into the trap of thinking it's just if it's got movement. It is any type of joint that you must apply this to. Okay, external waterproofing membrane. So I've only highlighted point number 2 here because point number 1 existed previously. It's nothing new. It says that we need to have compliant waterproofing materials and they need to be installed in accordance with the standard, right? What is new is that this compliant membrane, where it's required to be applied to a concrete roof, balcony, podium, or similar horizontal surface, it must be installed directly on the structural substrate. Keep in mind, before we identified that our structural substrates are only reinforced concrete, fiber cement sheet. So if you're reading between the lines, this is taking out screeds, which I'll talk about in a moment. But before we do, what comes before you actually apply a membrane? Substrate preparation. So in order to apply a membrane to a substrate, you need to prep it, right? So grinding it, no problem. You're just changing the profile of that structural substrate. You wouldn't grind an FC sheet, but reinforced concrete's no problem. So that's okay. But with the current wording, and again, this is something that I have no doubt will be addressed in changes. I put my own public comment in about it. If you apply a repair mortar, a leveler, or anything of that sort, well, that's not technically reinforced concrete in accordance with our AS 3600, right? So if we're applying a membrane over these repairs, we're technically non-compliant with those clauses. So I'll just put a couple of other examples up here. Same thing. So we're yet to see how this will be addressed, but a logical accommodation might be to say that you can do localized patch repair to up to 10% of the concrete surface area or something of that effect, which means you could easily do your set downs around the perimeter. If your concreter stands on the timber and all of a sudden you have a big rebate in the set down, you could do localized repairs on those, but there would be a limitation and an accommodation there. So we'll wait to see what comes out of that, but this is currently the state of it. So nice little diagram here showing a waterproofing membrane applied to the structural substrate. Pretty simple. So that gets our compliance tick. And then we've got a comparison here where we've got half right, half wrong. This is a diagram that shows the two options which are very commonly employed in, say, internal wet areas or balconies. This is a balcony here. On the right-hand side, we have our waterproofing membrane applied to our structure, FC sheet in this instance. And on the left-hand side, we have a waterproofing membrane applied over the top of the screed where falls have been achieved. Now, I will note that the one on the right is also technically non-compliant because there doesn't appear to be any fall in the structure there, but just for the purpose of this particular clause, the membrane has been applied to that substrate correctly. So this, I'll just touch on this one really quickly as well, is warm roof buildups for anyone that's in this space, remedial space, condensation management. Tim, I'm looking at you. We're effectively applying our PVC sheet membrane. And this is a really good buildup, by the way. One of the best things you can do with your building. We're putting it over the top of our insulation. So technically our waterproofing membrane is being applied on insulation, not on the structure. Another detail that shows pretty much the exact same thing. Now, you might be wondering why, if this is non-compliant, I said it's a really good detail. It's just not covered by the DTS provisions at the moment. You always have a performance-based pathway, and I'd be extremely happy to validate the performance of this system because it does work really well. Okay. Now, damp proofing. We've effectively just removed our class 7 and 8 exemption here. You've got to remember, a lot of people will look at class 7 and say it's car park. Well, what's the problem? Class 8s also include laboratories. Class 7s do include warehouses and stuff as well. These areas can be definitely very sensitive to moisture. So having these exemptions removed, so we're forced to think about, are we doing enough? Makes a lot of sense. No change for damp proofing. Surface finishes. I won't talk too much about tiles and pedestals because I think Ross covered it very well. So we've got two surface finishes. They must be either self-draining, such as our tiles and pedestals, or say a timber deck as well, less common, but still complies with A, or B, directly fixed with the membrane. And that's the one I want to talk about. So in this scenario here, you can see that we've got our FC sheet system. We've got our waterproofing applied directly to our structural substrate. Great. And then we've also got our surface finish directly applied to the membrane. So now we're adding up all of these clauses that we've been talking through at the moment. And I hope I haven't lost you. We're adding them all together to say, okay, this is what a compliant buildup looks like now. And I'll just look something to the contrary. When we put a screed in here, even though we have our waterproofing membrane directly applied to the FC sheet, when we put our screed in, our floor finish being the tile is no longer directly bonded to our waterproofing membrane. Cool. So 11, 12, 13, no changes. 14 is for glazed wall assemblies. We've again removed those exemptions. So yes, things that we weren't previously thinking about, we now have to validate, be aware of that. And finally, we've had this added in. It's not in the waterproofing DTS provisions, but it is a new structural provision. And the key word there is that we now need to calculate the expected 10-year deflection for structural substrates. Reason being, as Ross said before, you have deflection, you didn't have ponding before, you now have ponding, entrapment of water, and inevitable failures. So I moved through that a little bit quickly, I know, but I want to recap now to sort of really just drive home the current state of it. Does anyone want to guess what our 4 key points for DTS compliance were? Anyone brave enough to put their hand up? Be a prize in it for you later. Yes, we've got one.
All in the structural substrate?
That's exactly right. That's one of them. Anyone want to pull another one? Membrane directly on the substrate. That's exactly right. And what does our substrate have to be? Concrete or FC sheet. That's exactly right. There's one more I'm looking for. 70 mil, yes, that's in there. It's actually combined into one of them, so that's awesome. What about the floor finishes? What do we have to do with those? Directly bonded to the membrane. So we'll reveal all of these now. This is really everything boiled down. All of those changes boiled down into these 4 key points. So definitely grab a photo of that one so you can have a think about it later. Cool. So this might be a bit of a change, right? There's tilers that have been doing screeds forever. We're now saying that you need to direct bond your finishes. We need to do all of these things different. Well, it's not as bad as you might think, because I'll take you back to how the NCC actually works. And while we do have those DTS provisions that say, if you do this, it will be compliant and it will also work, which is the point, we do have another pathway as well outside those. And that is performance solutions. And this is a really cool diagram, really well done, which shows what those 2 different pathways look like. On the right-hand side, we've got deemed to satisfy. We've got our types of evidence there, which I won't read out. And then we also have our performance solution on the left-hand side. So we can go down that pathway of performance solution. It is possible to build things with screeds, with a membrane on a screed, with various types of buildups that will work. It's also possible to build them so that they fail, which is what's happened, which I know Ross will say was a massive catalyst in making those changes. So what does it really mean for us? It doesn't mean that we can never, ever do those things that you're probably familiar with conventional construction. It means that you have to think about it and prove it. That's all performance solutions are. They shouldn't be scary. There is effort that needs to go into them. But really, it's just saying, if you want to do this now, prove to us, the certifier, the owners that are going to have to live in it eventually, prove to us that you've thought about everything that could go wrong here and that you have something in place so that you know it will work. So, on to part 2. I'm running a little bit behind on things, so we're going to push through pretty quickly, but these are all pretty straightforward. So, what I've done here is, I should give a bit of a preface here in why I really wanted to talk to you about this. So, we've been doing something very similar in New South Wales for the past 3 or so years now, right? And that's what I've got as the transition. I think after reading through the documentation practice guide, it takes all the good things out of what we're doing in New South Wales, adds in some extra things which make it even better. So I think you're off to a really good start by building on a foundation and learning from the mistakes that we've gone through in the past 3 years. So that's a really good thing. And these are a map. Made my team do a bit of work here, map out every project that we've done, designs under the Design Practitioner's Handbook is what we call it in New South Wales. So I've done quite a few of these, right? So I'm a little bit qualified to talk about what you need to do. Now, this is the purpose of the guide. For the sake of time, I won't read the whole thing, but the point in bold there says that the documentation package must contain sufficient information to show that the proposed building work will comply. If you don't draw something, you don't have a section detail of how to detail an overflow, you are not showing how your building is going to be built that's complying, right? So that's really the name of the game, is to show what we're going to do The building certifier can have RBS can have a look at it, and they can say, I see what you're doing, and I agree that it's good. So what does this look like? Well, I'm going to read through the clauses, and these are the things I've picked out that are specifically relevant to waterproofing. There's a lot of non-waterproofing stuff in there. This is just waterproofing. So, point 122, building enclosure. Construction methodology details the waterproofing habitable areas below ground. Pretty important. This is a nice diagram of what an effective waterproofing of below ground space would look like. Waterproofed wall, structural wall system. I believe this is a Dinsel system. Dinsel is one of our sponsors. If you want to talk more about this particular junction and the warranties that they offer, have a chat to them and have a look at their model outside there. Then we've got an internal maintenance passage, which controls the humidity. And then we have the habitable space on the inside there as well. Cool. Moving on. Section 1.2.3, waterproofing internal. We need to have layout plans. There's a whole lot of things that those layout plans need to show, such as extent of waterproofing, location of water stops, drain points, falls, and so on. That's actually detailed really well in the guide. I've just got some examples of what that would look like up here. We also need to show elevations. That's a little bit of an old one, but it does clearly show the extent of various membranes. And then we need section details. Devil's in the detail. Where things go wrong is normally where a section or a junction has been poorly detailed. And I have a good example of that a little bit later. So now we move on to external. External, again, we have layout plans showing our membrane and other things, and then we have section details. So one thing to be aware of is that our layout plans are 2D, right? We build in 3D, so we add in section details to give us that information on what's happening vertically through there, so that we can actually build it effectively. Balustrades and handrails. This is mainly a structural provision, but it does wisely include a requirement for the waterproofing detail and how these will be detailed. And the design barrier should be considered not to compromise other building elements such as waterproofing and reinforcement. We see quite often that they're an afterthought. Waterproofing goes in, or the building finish goes in, and then come in the fixings and the base plates and just punch straight through everything. So talking about how we're not going to do that is a great idea. We also have a little bit in lifts. Lifts, you don't want water in your lift, so you need to actually show how that's going to be achieved. And lastly is the waterproofing schedule. So this is a breakdown of all those different locations that are shown on our layouts. It talks about the risk in those areas, the product types, the primers, this is probably a little bit more detail than maybe is needed there, but it shows exactly what products we're going to be used, because it's very easy and very common to use a good product in the wrong location and get a bad outcome. Cool. Oh, we do have one more. So design loads, we also have this section talking about joints. Your design documents must show how they're going to accommodate structural movement, and we have a very basic movement joint here as well. And to wrap it up, I really like this part out of it. This is written in. It says, the design practitioner, typically an architect or an engineer, should consider consultation with waterproofing consultants, professionals, or waterproofing industry bodies. AIW is here to help. We're actually encouraging a lot of certifiers, architects, builders to become members as well, to access what we have to offer. Prior to the selection of product or system. This is actually really wise. Not much longer, mate.
No, all good.
This is actually really wise and a rule that we follow. We often have a lot of our clients wanting to jump the gun so they can tender it out and say, let's select our products and so on. You don't know what products you should be selecting until you have a design in place. And you achieve that design by consulting, as this indicates. So I just wanted to give this one real quick example of why it is really smart to get your design right on the front end. This is a extremely logical measure twice, cut once scenario, and this is the difference in outcome. On the left-hand side here, you can see a great interface between our waterproofing system and our weatherproofing system in facade. Typically, these will be two different parties that work somewhat independently, and it's not, if you don't have coordination in design, then you're going to end up with something like this, where facade handles the vertical, they've got the sarking, they've got everything in there, it runs down, and then the waterproofer comes in later because no one thought about it. They apply their waterproofing, they turn it up on the outside face of the brick, water's now trapped in the bottom of the wall like that. So this is a quick QR code if you're interested in having a read of the VBA Design Documentation Practice Guide. You can do a quick scan of this. It's a nice PDF, so I recommend you grabbing a copy. Sorry if I was a bit too quick there, guys. And that is everything from me today. I think I'm right on time. This is a QR code there too if you want to contact me about anything, any questions related to the presentation. I'm very happy to talk about it either later or throughout the day. So thank you very much, everyone. I really appreciated talking to you.
Thank you.